Let's go over the geometric sequences, covering the recursive form and the explicit form, and I do have 5 examples. Let's get started. For example number 1, write an equation for the nth term, a sub n, of the geometric sequence given to us 5, 10, 20, 40, 80, and so on. Now it's claimed to be a geometric sequence, so it acts like a geometric sequence, meaning as you move forward, you have a number that you keep multiplying by, which is constant, the same number. Dividing backwards, you could find it, which is called the common ratio. If you notice, we have 80 divided by 40 right here, that will give you 2. Dividing 40 by 20, that gives you 2. Dividing 20 by 10 gives you 2. Dividing 10 by 5 gives you 2, which means as you move forward, we are multiplying times 2. Every time we go forward, we multiply by 2. Multiply by 2, 20 times 2 is 40. 40 times 2 is 80. So R is 2. To make it more clear, I have a sub 1, which is 5, a sub 2, which is 10, a sub 3, which is 20, a sub 4, 40, and a sub 5, or the fifth term, is 80. But what is A1? A1 is just 5. And A2 is 10, but I could look at it this way, 5 times 2. And A sub 3 is 20, but 20 is 5 times 2 times 2 again. 40 is A sub 4, which is 5 times 2 times 2 times 2. That's 5 times 8. And 80 is A sub 5, which is 5 times 2 times 2 times 2 times 2. Clearly, that is 5 times 2 to the power 0. Anything raised to the power 0 is 1. So, no more 2's in it. This one is 5 times 2 to the power 1. 5 times 2 to the power 1. And this is 5 times 2 to the power 2. This is 5 times 2 to the power 3. And this is 5 times 2 to the power 4. Notice that what we have here is, if we are looking at a sub 5, if we're looking at a sub 5, this is 4, 1 less. For a sub 4, we have 3 here, which is 1 less. And for 3, we have 2 here, which is 1 less. So for a sub n, the exponent that goes on top of the common ratio is 1 less. N minus 1 means 1 less. And that is the explicit formula for the geometric sequence. In this case, we have the following. A sub n equals a sub 1, that's the first term right here, 5 times the common ratio is 2, that you keep multiplying by, to the power n minus 1. And it's that simple. Now, it's not always that clear, but this is a good example to start with. As you could see, clearly we could see that the first term is 5, and we multiply by 2. But sometimes you cannot see that it's a 2. It could be like a decimal that you multiply by, so you need to find it dividing backwards. Dividing 80 by 40, you give 2. 40 divided by 20, you get 2. That's why it's called common ratio. This is what I mean. So when you go back this way to find R, 80 by 40 is 2. Dividing 40 by the previous term, which is 20, you get 2. And you divide 10 by 5, you get 2. This is the common ratio. This is a common number, which is a common ratio. That's why it's called ratio, because we're dividing backwards. and that is R, the common ratio, which is 2. Example number 2. Write an equation for the nth term a sub n of -1, 3, -9, 27, and so on. Now clearly we have a sub 1 is -1, but going forward, if you could see it, that is the common ratio. I believe we could see it that it's times -3. -1 times -3 is 3, and so on. Or you could do it backwards. 27 divided by -9, that is -3. -9 divided by 3 is -3. 3 divided by -1 is -3. This is the common ratio. R is -3. So we know the common ratio, and we know the first term, which is -1. So the formula is a sub n equals the first term, that's -1, the common ratio, which is -3, to the power n minus 1. Or we could write it as negative, instead of -1, times -3 to the power n minus 1. That is example number 2. Let's go to example number 3. Example number 3 says a sub 8 equals 5 and R is half. So we know R, which is half, but we don't know what's the first term. We're gonna use what's given, a sub 8 equals 5, to find a sub 1. So we have a sub n equals a sub 1 times R to the power n minus 1. When it's 8, when n is 8, a sub 1, we don't know it, so let's just leave it as a sub 1 times R, which is half the common ratio, to the power n minus 1. In this case, it's 8 minus 1. So I could replace a sub 8 with 5, a sub 1 still there, unknown, times half to the power 8 minus 1, that is 7. Using the calculator, you could evaluate half to the power 7, and that is 1 over 128. To solve for a sub 1, I'm going to multiply both sides by 128 over 1. This cancels and leaves a sub 1 alone. I have a sub 1 equals 5 times 128 over 1, which is 640. Now I know what is a sub 1, which is 640. The formula becomes a sub n equals 640 times half to the power n minus 1. And that should do it. Number 4. It says recursive and explicit formulas. Given a formula for a geometric sequence in recursive, I have it on the right side in green. That's a recursive form. So it relates any term to the previous term, because that's how you go forward. From any term to the second term, you multiply by R. Or the explicit form, which is written right here, the one that we used for the previous examples. Of course, R is the common ratio, a sub 1 is the first term, and that's the nth term. Now, in example number 4, we have a1 equals 5, and we have a sub n equals. So which form is this one? Is it the first or the second? Let's take a look. It says, Given a formula for the geometric sequence in recursive or explicit, translate it to the other form. Well, this one has a index n-1, not an exponent, and that is an index right here. So that should be this one right here. Let's take a look. So we have this form is connected to this form. That is the recursive form. We need to find the explicit form. Let's be more clear and make it detailed. Here we go. Now, we agreed that the form that is given to us is the recursive form, the green one. And as you could see, we have a sub n minus 1, a sub n minus 1, a sub n minus 1. We have in the front r, that is the common ratio, and we have a sub 1 equals 5, which we needed for the formula. So that says that we have a sub 1 equals 5 and r equals 1 over 5, 1/5. The explicit form, the other form, is in red, will be a sub 1, that is 5, which is right here, times r, that we agreed on as 1/5 to the power n minus 1. And that should do it. One more to go. Number 5. For number 5, it shows that we are given a sub n equals 2/3 times 7 to the power n minus 1. So which form is this? Is it the recursive form or is it the explicit form? Well, going back and forth, we could see an exponent right here, and that has an exponent, a number up front, a number up front, a number up front. That doesn't give me much, but I need to look right here. This right here, does it look like a sub n minus 1, or is it like r to the power n minus 1? Well, clearly it's this form right here. As you could see, to the power n minus 1, both they say to the power n minus 1. So we have the red one, we need to find the green one. Let's make it clear in a new slide. So this is what we have. We have the explicit form, meaning I could say that this right here is 2/3 goes with a sub 1. So we know now a sub 1. We know also r as 7. That is so clear. To move forward, we need the recursive form, which is in green, and let's write it down first. What we have a sub 1 equals 2/3, and we have r equals 7. Now a sub n equals r, and r is 7, times a sub n minus 1. And that should do it. We're done. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.